Hello everyone, and thanks first of all to Kevin for the introduction and the invitation to present here. I'm delighted to be here. I'm going to be talking about student migrations or student transitions from secondary schools to higher education institutions. So this is a particularly fitting place for me to present this particular paper because I'm embarrassed to say that it's, I think, nearly 24 years ago, 1992, that I made the transition from Waterford to UCD. I lived over in Merville for the first year, and I lived in Belgrave for the second year that I was here in UCD. So it's really nice for me to come back. I took a little walk around this morning just to see my old stomping grounds, and many of the ideas that I have in relation to the sort of the wider spatial economics of higher education participation in Ireland are sort of framed by my own experiences as a school leaver in Waterford in 1992, and the decisions that I made in relation to where I would study also compared to decisions that my friends were making at the same time. And I'm going to come back to that right at the very end because I think it's an important part of the story. So the specific paper I'm going to present today is a school level gravity model of student migration flows, these are school leaver migration flows to higher education institutions. It's an Irish study, and it's joint with Jim Duggan, who is a lecturer in information technology in NUI Galway, and Jim's role in this project will become evident as I talk through the data that we analyse. So this is just a very quick sort of overview of what I'm going to talk about. There'll be some context and motivation for the research. I'm only going to do a little bit of literature here, focusing on previous Irish studies, and then I'm going to speak a little bit about gravity models. I won't say a whole lot about the theoretical underpinnings of gravity because I don't know a huge amount about it, but I will talk about the empirical specification and estimation of gravity models because that's something that this paper focuses on quite a bit. There'll be a bit of discussion about the data because we pull data from lots of different sources, so I want to give you a sense of some of the challenges that we faced in doing this research, and then obviously focus on the results of the analysis. And I'll talk a bit about the conclusions of this piece and how it links up with some of the conclusions we reach in some of the other work that we've done to try and give you a sort of a broad sense of what it is we think are the important issues and policy implications in relation to how location and where people are born and how far they have to travel to go to higher education impact on a range of different outcomes. Okay, so in terms of sort of very, very broad context or motivation for the work, I think most people here would probably agree that there's a very important role for higher education in economic and wider social development. And, in Ireland, for example, we've seen very high increases in the overall participation rates in higher education over the last sort of 10, 20, 30 years. Increases in higher education participation is a very, very important policy objective, not just in Ireland, but in many countries. And as a result, what we've also seen over the last sort of 10 or 20 years is a huge amount of research which looks at, say, the determinants of higher education participation. So what is it about individuals that impacts on their likelihood of progressing to higher education or making specific choices in relation to where they might participate, for example. So some really good economics research. So a lot of the economics research is focused on socioeconomic and family background, for example, on the role of economic incentives. So in Ireland, the issue of fees, and Kevin has done some really nice work in that area. And then in the wider international literature, lots of work done on network effects, on peer effects, and a whole host of other factors. But it's not really just overall participation rates that are important within the policy context. Equity in relation to higher education participation is also generally considered to be a very, very important part of the story. And in lots of the policy documents, you'll see it explicitly stated. That policy we should strive for greater equality of access in higher education participation. But despite that, unfortunately, there's significant evidence that large inequalities in access persist. And these inequalities exist across a number of different domains, across social class or socioeconomic status, for example, across disability status, and as I'm going to show today, also across geographical locations. So within that sort of context, if we think about accessibility to higher education, and if we think about inequalities in accessibility to higher education, there's a number of different sort of factors that have been explicitly considered within the sorts of literature that I referred to earlier. And they mainly relate to, I suppose, individual financial resources when we think about differences in socioeconomic participation rates or gradients in social participation rates across social classes. So a lot of work has been done looking at individual financial resources and how differences in resources might lead to differences in participation rates. But increasingly, there's been an increase in focus in how so-called distance effects, which I'll define a little bit more explicitly in a moment, how these distance effects might also lead to inequalities, be they geographic inequalities or be they an exacerbation of socioeconomic inequalities. And within the context of what I'm going to talk today, it's worth noting that distance effects are considered quite important within an Irish context. So Patrick Clancy, in a number of pieces of work, has shown previously that Irish higher education is highly influenced by geography, and I'll show you some numbers on that subsequently. And then Philip has done work in the past which has shown considerable variation in county progression rates, say for example, to higher education in Ireland. So distance effects, which I'm going to focus on today, certainly matter for Ireland.
Are these distance effects that people have found, are they conditional on the Leaving Cert scores?
So some of them are and some of them aren't. So some of the work that I've done previously would be controlling for differences in CAO points.
You take account of Leaving Cert performance?
Absolutely, yeah. So the the specific types of distance effects that economists generally tend to think about are nicely summarised in a paper in the Economics of Education Review in 2010 by Spiess and Rolik. And the main type of distance effects are costs that arise due to large distances between where you live and, say, for example, where you might want to study, are so-called transaction costs. And these are the very obvious direct financial costs, say, for example, of the cost of commuting from your home to a higher education institution, or moving out of your home to attend and live in a new city, for example, to study. But there are also indirect financial costs, say, for example, foregone economies of scale from living at home. You no longer have those if you move out of your house, for example. There can be search costs associated with, having to move or living further away from a higher education institution. There are information costs. It's just more difficult to find information sometimes. And there are also, apparently in the literature, emotional costs associated with, leaving home to study in a faraway city. One of the things that I often think about when I think about these emotional costs, however, is that I'm pretty sure my parents experienced an emotional benefit when I left home at 17 to come to UCD, but I haven't seen any reference to those sorts of benefits in the literature. There's also what are known as neighbourhood effects, and these basically relate to the greater likelihood that people growing up in the near vicinity of a higher education institution, the greater likelihood they will have of attending that higher education institution or maybe another one. And it's just that there's something in the air if you live close to a university. Say, for example, there can be extra peer group effects whereby everyone in the local vicinity is going to that local university, so you become more likely to go. And there are also additional information network effects. If people who live close to the university are involved in the university, it's easier to get information. So both these transaction cost effects and the neighbourhood effects basically, in a nutshell, imply that if you live close to a higher education institution, you are likely to be, you're more likely to go to higher education, and you're probably more likely also to attend the specific higher education institution that you live closest to. So that's the very broad sort of background to the piece of work that I'm going to present today. Before I get into the specifics of the paper, however, I want to just talk a little bit about some literature that I think is relevant to the wider context in relation to these sorts of distance effects in Ireland. And I'm going to be a little bit self-indulgent here because I'm only going to talk about my own research, so I'm not going to talk about research that's been done by others in other countries, but most of the work that's been looking most of the recent work that's looked at these issues has been work that I've done with Dara Flannery, who's a lecturer in economics at the University of Limerick, Sharon Walsh, who's a PhD student of mine at NUI Galway, and then we did one paper with Selena back in 2013, which was published in the Economic and Social Review. And this is what really, I suppose, sparked my interest in the area. What we found in that paper was that overall, on average, these distance effects that I've been talking about, they don't matter at the average in terms of the overall probability of participating in higher education. So we used individual level data from the School Leaver survey, and we basically looked at the relationship between the probability of progressing to higher education and how far you lived from your nearest higher education institution. And if you run a simple binary logic regression, you find that distance has no effect at the average. But what we did was we interacted distance with social class, the social background of the student, held constant their CAO points, so how well these students had done on their Leaving Cert, for example. And what we were able to do is we were able to tease out that distance has a differential impact for students from poorer backgrounds than from better off backgrounds. So you're much less likely as a poorer student, if you live further away from a higher education institution, to go to higher education than if you live close by. Those distance effects don't result, are not in effect for students from richer backgrounds. And the reason for that basically is they have the financial resources to overcome the costs associated with living further away. So it's one of the reasons that you see these socioeconomic inequalities in terms of higher education participation, is that the students who live further away and are poor, they're basically unable to overcome the costs and therefore participate. We also found, which I think was quite interesting, is that those sorts of effects for younger or for poorer students were much more pronounced for students who didn't do particularly well in their Leaving Cert. So if they got 340, 350 points, for example, which is still good enough to go to higher education, certainly you can get into an Institute of Technology or university on those points, those distance effects are much, much more pronounced for lower achieving students. If you do have a student from a higher social class, or from a lower social class, who does particularly well, gets 500 points, for example, then those distance effects don't become as pronounced. There's still a small effect, but basically, kids from poorer backgrounds who do particularly well, they will find a way, or their parents will find a way to get the money in order to overcome the distance effect. So this basically the piece of work which sparked my interest in this area, and Dara and I built on it then in a paper in Applied Economics a year later, where we looked at not the decision to go to higher education, but once you've made the decision to go, to what impact does distance have an effect on where you might go, what type of institution you might attend, what type of course you might study, and so on. And what we found basically was, in this case, the nearer you live to a university and the farther away from an IoT, that will have a big impact on you going to a university, all else equal. But if you live very close to an IT but very far away from a university, then you're considerably more likely to attend the IT and not go to university. And that has impacts in terms of, we also found effects in terms of the likelihood that you would study, say, a higher level course or a lower level course, and specific types of courses. So much less likely to study, say, if you live close to an IT but far from a university, much less likely to study medicine, much less likely to study social sciences, and so on and so forth. So big implications, again, with distance in terms of not just where, if you go, but where you go and what you study, which I think is interesting. And then building on that, Sharon, in a couple of papers, the first couple of papers from her PhD, she sort of moved beyond that sort of individual level microdata analysis and said, well, there does seem to be these distance effects, but to what extent is geographic inaccessibility or poor accessibility to higher education a problem? So we have a couple of papers which basically look at using GIS techniques to measure the extent of geographic inequalities to higher education in Ireland, and we find we have pretty good accessibility to higher education overall, but wide disparities in terms of accessibility to universities. Okay, and if you plot the point locations of universities on a map and look at spatial distribution of them, you can see it's obvious enough where the areas of poor accessibility are. So that's one of the things we did in this paper here. And then we built on it in this paper that's forthcoming in Applied Spatial Analysis and Policy, and we did a couple of things. We looked at much more sophisticated measures of accessibility. We looked at Gini coefficients, looking at inequalities in these accessibility measures. And we also then modelled the restructuring, or the proposals for the restructuring of the higher education sector in terms of the amalgamation of ITs into technological universities, to try and model what are going to be the impact of these changes in terms of accessibility. And we find, you know, the areas that do badly now in terms of geographic accessibility, they're going to continue by and large to do poorly once we have these amalgamations. So that's basically what we've done so far in this sort of program of research. We're also doing a few other things which I'm hopefully going to get back to talking a little bit about at the end. There's the paper that I'm going to talk about today, the gravity model. Sharon is doing a discrete choice experiment at the moment, which is looking at how students or school leavers trade off different characteristics or attributes of higher education institutions. How much are they willing to give up, say, how far are they willing to travel, say, for example, to go to a university vis-a-vis an IT, or a course with high course reputation versus low course reputation, or a university that has a work placement versus not, say, for example, and we're finding some interesting results there. We've just started a couple of pieces looking at path dependence and peer effects in higher education participation, which is an important part of the story, but something we couldn't address in any of the previous analyses that we've done. And then the final piece that I'm working on at the moment is sort of pulling together all of the stuff that I've been talking about and this ongoing work. And I'm doing a book chapter at the moment with Brendan Halpin from the University of Limerick, where we try and just put all this together in terms of, you know, taking the various pieces of the jigsaw to talk about the spatial economics of higher education. So really with a view to sort of what do we know from all of this work, and what policy conclusions can we draw. And I want to come back to that at the end, because I think you might be interested in it. Okay, so bit of a long introduction, my apologies for that, but what I wanted to do was sort of really set the context for why it is this paper becomes relevant and what's useful from this paper and what it is that the gravity model can add to the literature that we have to date. And so just by way of introduction to gravity models are traditionally used to model bilateral trade flows. I think that's probably the original application of gravity models in economics, certainly, but they also have been extensively used to model migration flows, often between countries or within countries, say within states of the United States. And in this context, what the gravity model of migration is going to allow us to do is to consider the distance effects that I've been talking about from a different perspective, because some of the earlier work that I've done has sort of used individual level survey data to sort of model individual choices in terms of where people go or what they do as a function of distance. Now what we're going to do is we're going to model flows of students between two places, and that's going to give us a range of alternative insights that we can't get from the micro level data analysis. And just one thing to point out here is that any of the previous studies that have looked at these sort of migration or gravity models of student migration, they've typically tended to model flows of students from, say, an area like County Kerry to an area like, say, County Dublin. So you can imagine all of the students in County Kerry moving to all of the universities and HEIs in Dublin. That would be a flow from one area to another. We're going to do something different in this paper in that we're going to model flows from individual schools to individual HEIs. And that's very different to all of the previous work in the literature. So the gravity models themselves are derived from Newton's law of gravity. So this is about all I know about Newton's law of gravity, but I think it's pretty it's pretty straightforward. The idea here is that any two bodies are likely to attract one another with a force that's proportional to the product of their masses and inversely proportional to the square of the distance between them. So if we think about what I'm going to try and model here, which is the relationship between the flows from a school to a HEI, we can think about the masses of these two bodies as being the size of the school, or the number of students doing the Leaving Cert, or doing the Leaving Cert and progressing to higher education, say, for example, and then the mass of the other body is just the size of the university or the number of incoming undergraduates. And what we do is we multiply those together. Okay, the product of their masses is the size of the school by the size of the HEI, and then it will be inversely proportional to the square of the distance. We're basically going to divide by the distance squared between them. And in our paper, we do something that hasn't been done in all the other papers. We model the network travel distance between the school and the HEI. So we use a sort of a Google Maps type thing where we can calculate what's the travel distance between the two. So
you divide by the square.
Well, yeah, the square of distance. So this is actually a much better way of thinking about it, for me at least. If we formalise that sort of previous description of the gravity model, forget the A for a minute, what we have is migrations from school I to HEIJ is equal to the size of the school, so PI, multiplied by the size of the HEI, and then multiplied by the distance to the power of, say, 2, so we estimate this, or minus 2 would be actually, the distance between the school and the HEI. So this is essentially the PI, PJ, DIJ is the formalisation of Newton's description of gravity. And you know, obviously what you would do is you would look to estimate these parameters. And in the description that I gave you previously, that would be equal to minus 2.
Yeah.
But it turns out not to be.
Well,
it has to
actually,
be something else.
Actually, it shouldn't be minus 2.
Yeah. Okay. So I'm going to show you where I got that from a minute, in a minute. And
but the physics, actually, Newton's law, the square rule comes from three-dimensional space. On a two-dimensional space,
yeah,
it depends on the power of 1. In k-dimensional space, gravity depends on the k minus 1 power of distance.
Okay.
So actually, it is the level, not the square.
Which is good news, because when I estimate this, I estimate it pretty much to be close to minus 1, so that's good news. Yeah.
Well, the general relativity gets even more complicated. We won't go there.
So this is a physics rule, not an economics rule. So does it really matter that you're... I feel I'd have more confidence in this if it were based on some sort of economic reason why you think it would potentially be squared or whatever, rather than...
But in gravity models, you generally get a power of 1, which is actually quite close to what... by coincidence or otherwise, is what you would expect in physics.
Anyway.
You'd expect there would be barriers, right? That if you're close enough to live at home, that's
I know you're here, yeah.
So, can you say that again?
Being close enough to live with your parents is probably discrete from the probability of going to an institution.
Yes, yes.
You'd expect it wouldn't be continuous, the effect of distance.
Yeah, so I think that's fair enough, and I'll come back to that in just in the next slide, if that's okay.
I'm curious, why are you looking at the total flow rather than say the proportion of students from the school that go to a certain... Would it be easier?
I don't think so. I mean...
We wouldn't have to worry about the size of the school.
But it's easy to control for that. So, again, I'll come back to that. Okay, so the idea is that if we do model these flows, sort of the three key parameters initially from the previous definition are the sizes of the institute, the school, and the HEI, and the distance between them. But there's likely to be other factors, like Paul has just said, that are going to be important, and we refer to these as school push factors and HEI pull factors. So you can imagine there'll be certain things about certain schools that might push you towards a certain HEI, a certain type of HEI or something like that, and there'll be certain things about UCD that will pull students towards it. Okay, one of those push and pull factors is size. So we would have the size of the school is going to be an important determinant of how many students flow out of it, and the pull factor is going to be UCD takes in more students, you know, than Maynooth, so there's going to be greater flow. And by incorporating these push and pull factors into this funny looking term here, okay, we can account for a range of different factors, and I'm going to tell you what ones we do. And we would like to estimate alpha, beta, and gamma, which are the parameters. Yeah.
So John, this piece of I, is that total flow of students from school to higher education rather than the total outflow from leaving cert?
It is the total flow of students from school I to higher education.
In general?
Yeah, in general. Now, I've modelled it two ways. I've also modelled it as the total number of students who do the leaving cert in that given year. It makes no difference to the key parameters that we're interested in. Likewise, you can have the overall size of the total student, say the total number of undergrads in UCD, or the total number of new undergraduate entrants in a given year through the CAO process. Because ultimately what we're thinking about here is we're thinking about school leavers coming into as new undergrads through the CAO process into UCD. So that's what we use in our model. So given this sort of setup, this formalisation, the sort of standard approach then is to linearise the model, take logs of both sides. So we have the log of student flows between each school and each HEI. We have this fella for a moment. And then you'd have the log of the size of the school, the log of the size of the HEI, and the log of the distance between the two. And one of the reasons that that sort of log-log linearization is used is that these parameters here, the alphas and particularly the beta, can be interpreted as an elasticity. So, Paul, just going back to what you were talking about there, and you could have these stepwise kind of effects. We don't address that. We just consider the elasticity of student flows with respect to distance. So for a given proportionate increase in the distance away from a HEI, what will be the change in the proportionate change in the flow of students from a school to a HEI? And that's kind of standard fare in this gravity model literature, would be to take something like this, stick an error term on the end of it and just estimate it using ordinary least squares, or you could sort of re-specify this a little bit as a Tobit model and then estimate it via maximum likelihood. And that's the standard way in which pretty much all of the gravity models of migration, certainly in relation to higher education migration, have proceeded. But we do something different, and I'm going to come back to it. And the reason we do something different is that these flows from school I to HEIJ, they are more like, look to me, like count data. And we estimated, said, count data models, and we forgo the sort of general approach of taking the log-log version of this and estimating it using OLS. So that's the gravity model approach. And what I want to do now is I want to talk about the various data sources that we used in order to estimate this model. And the reason I want to talk a little bit about it is we had to do quite a bit of work, which if I'd waited a couple of years could have become a lot easier for me, and I'll explain that in a moment. But we did have to pull a range of different data from a range of different data sources. So we needed, if you want to think about that previous equation, we need data on student flows from every school to every HEI. We need to know the school size, and we need data on the other push factors. The sizes of the HEIs, easy enough, and the other pull factors, and then estimate all the distances between all of the various bodies. So the first thing that we did was, back when we were looking at trying to get student flow data from every school to every HEI, at the time a couple of newspapers were publishing school feeder school data, but they weren't doing it for every school, and they weren't making it publicly available to people like me who wanted to do research on it. And it turned out at the time what these newspapers, I think the Irish Times and the Sunday Times, were doing is they were doing an FOI to all of the universities, and they were asking universities where are your students coming from, and they were tabulating them, and they were publishing part of the data but not all of it. So it wasn't good enough for us to be able to use, but there was one data source that was available which had all of the information that we needed, which could give us all of the flows from every school in Ireland to every HEI. And it's this website called schooldays.ie, which is a pretty unique resource. I'm not sure exactly who runs it because it's not overly clear, but they publish a huge amount of information in relation to primary and secondary education in Ireland. And one of the things they present are these progression numbers from say, for example, my old school, De La Salle College in Waterford, which showed that in 2013, which is the year we estimate the data from, there were 200 students, I know you can't see it back there, sorry folks, 200 students who sat the Leaving Cert, 22 who went to UCD, 6 to DCU, and so on and so forth to all the different HEIs. Interestingly, for something I'm going to come back to, 98 of the 200 students who sat the Leaving Cert in that year went to WIT. And that was my experience. When I graduated from my Leaving Cert in 1992, I think there were 3 or 4 of us who headed off to UCD, and another 50 or 60 went to WIT. And that was just the way it was, and that was always the way it was, and still is, by the looks of things. And that data is available for earlier years, but it's less trustworthy, I think, for some of the earlier years because there are some missing HEIs. But we have a good bit of faith in the 2013 data because we were able to aggregate it across all the schools and HEIs and compare it to the aggregate statistics published by the CAO. So that was the first thing we needed. Unfortunately, though, the data in this format wasn't easily accessible. So that's where Jim came in. So I had bumped into Jim a week before, and he was telling me the sort of work he does scraping data from websites, and I said to myself, well, I've got a huge amount of data that I need to scrape. Basically, there are over 700 schools, and when I proposed to a couple of my PhD students and a couple of RAs that I knew that I had an exciting research opportunity for them to basically scrape all this data and input it by hand, there was a lot of no-nos. So I went to Jim, and Jim was able to take this data and, using a pretty impressive looking computer program, he was able to basically take all that data and put it into a nice spreadsheet for me in order to model. So that was where Jim came into the project, and without him I wouldn't have been able to access this data. It turns out now, because I saw it at Christmas when I was browsing the Irish Times when I was away in the States, that now the Irish Times are publishing all of this data. So if I'd waited a while, I could have just downloaded the data into a nice format rather than sending poor Jim off to write a huge amount of script to download all this data. So this is where the data came from. Where I learned about, and I apologise to the people at the back, where I learned about gravity models, and this was pointed out to me in a seminar that I gave in Galway last year. This is one of the dangers of using screen grabs for your presentations, because one of my students looked up and said, I thought you told us never to use Wikipedia as it goes back. There's a little W up here in this tab up here, which says gravity model of migration up here. So that was me being caught, basically, in terms of where I was getting my information from. The other good thing about this website is it gives us the roll number. Again, apologies if you can't see it. The roll number, which is the unique identifier for every school in the country, is available on that website, as well as a range of other information like the gender enrolment of the school, the religious ethos, if it's fee paying, and so on and so forth. So we can pull some of those characteristics, and we do, and use them as potential push factors in our model. So we have those sorts of that sort of information. We can use the roll numbers for the schools to figure out the DESH status. So a number of schools are designated as socio-economically disadvantaged, DESH status. So we're able to consider that as a potential push factor. The idea being student flows will likely be lower, all else equal, from those schools. We also geocoded all of the locations of the schools, so we were able to match it into the electoral district in which the school is located and pull out some of the standard deprivation measures in order to see whether or not deprivation in the area of the school was likely to be a factor. We did consider other ones, and I can talk about these at the end, but in the end we weren't able to incorporate them just because the quality of the data wasn't good enough. Local labour market conditions and public transport availability, potentially important. We weren't happy with about the quality of the data, so instead we just include county level fixed effects in some of our models to try and get away, or to try and account in some way for these potential push factors. On the pull factor side, much easier, because the HEA publishes a range of different publications, which includes information on HEA size and a load of other potentially useful pull factors. So these are the sorts of things we thought might entice students from a school to one HEI as opposed to another. Non-progression rates in a HEI, PhD graduates for academic staff, Web of Science documents for academic. Now, deep down we know that there are very few school leavers who are thinking, oh, I'm going to UCD because they have, mighty fine, impressive Web of Science documents for academic. But it is an indicator of institutional quality or research quality. There's a load of other variables that we could use, staff-student ratios, percentage staff for PhDs, so on and so forth. In the end, it turned out that some of these variables were not available for some of the institutes of technology that we were looking at, and others were highly correlated with each other. If you've got really good researchers, they're going to have lots of patents, and they're going to have lots of citations and lots of documents. So they were highly correlated. So in the end, we just had to pick a couple of these, and instead of focusing on them as, well, how do they contribute as push factors, we include them as control variables to at least sort of get at the notion of institutional quality.
Students want to go somewhere that's fun.
Yeah.
You don't have any problems with that.
No, and I better be careful because I know this has been recorded, and as an NUI Galway faculty member I better be careful, but that is something that we did think about. And in Sharon's work, in our discrete choice experiment, looking at the attributes. One of the important attributes we discussed and thought about during focus groups, etc., was, to what extent do do issues like nightlife and sporting facilities and other attributes of universities matter, and they do matter to students in making a choice, but we don't capture it usefully here with any good measures. I'll just say this very, very briefly, because it didn't turn out to be as big a part of the story as I had sort of imagined. You need to take account in these sorts of models for the fact that, our universities, say, for example, are, we've 4 of them in Dublin, and then we've got 3, elsewhere. So they're not all uniformly distributed across space. So we want to take account of the fact that some are more centrally located than others. So we do that via this centrality index. As I said, it doesn't turn out to be massively important, so let me just skip over this slide, and I can come back to it if anybody wishes. And then what I will talk a little bit about is what variables we included in our final model. So the dependent variable is student flows from school I to HEIJ. So the mean number of school flows is 2.011. So 2 students on average from every school to every HEI, with a standard deviation of 5.4. Okay, so that's important. We've got huge over-dispersion in our data. Okay, we've also got lots of zeros, because as you can imagine, there's lots of zeros from lots of schools to lots of HEIs. And the highest flow, single flow, is 103. There are 103 students from a secondary college in Galway, which I can't remember the name of, which I should, because I lived beside it for about 4 years, to NUI Galway. It's located really, really close to NUI Galway. And if you look at some of the feeder schools around UCD, you see these huge flows as well. Okay, so we've got kind of unusual data in that there's lots and lots of zeros, but a couple of very, very high numbers. And this is the variable we want to model. We model it as a function of a range of different spatial variables. So the distance, the network distance from the school to the HEI. We have county level indicator variables for school location in some of the models to try and capture these unobservables around the area that the school is located in. We have the centrality index measure that I talked about very, very briefly. And then we also decided to include a special Dublin variable, because Dublin is unique in terms of a number of factors relating to higher education participation. It's much easier to get to Dublin, say, for example, from the rest of the country than it is to, say, get to Waterford. So public transport availability and accessibility is much better in Dublin. But also Dublin is much more expensive than the other cities. So we were thinking that there may be various competing factors that might impact on students in their thought processes in terms of whether to study in Dublin or not. So we stick a Dublin dummy variable in some of our models. On the push level, school level push variables, so the ones we had and went for in the end were the total flow of students from school I. So this is the massive school I. We have 3 gender categories: boys schools, girls schools, and mixed gender schools. We had a Catholic dummy variable, a DESH dummy variable, and then we had a truth-task deprivation index. So they, again, apologies folks if you can't see any of the detail, but they're the final model variables that were included as school level push variables in the model. And then on the pull variables, obviously we had the school size, or the HEI size. We also had type of HEI, university, Institute of Technology, College of Education, which also included RCSI and NCAD. We had expenditure per student, and we had a staff ratio variable, which was non-academic to academic staff ratio. I wouldn't put a whole lot of store on some of the results associated with these variables. I think of them more as controls for, institutional quality and other, other factors that might
accommodation
didn't have a good measure, and also, it's certainly again one that Sharon. So one of the reasons that Sharon, apologies to keep coming back to Sharon's discrete choice experiment. One of the reasons we're doing a discrete choice experiment in Sharon's PhD is that there were kind of a number of questions that we couldn't answer appropriately with this data or with school leavers data that we looked at, and that was that was again one of the issues. So Sharon is directly addressing the issue of to what extent on campus. And again, it's the same thing. There's heterogeneity there. Some students love the idea that they can live on campus. To others, it's awful. They want to live, in the city centre, and there's a good bit of difference. Overall, we have 701 schools, 27 HEIs, 19,000 observations. So we've lots of data. I do want to say a little bit about how we estimated our gravity model, and the reason for that is that in the paper we make a big play about we make a methodological contribution. So I just would like to mention that there was a paper in spatial economic analysis a few years back which criticised that sort of standard log normal gravity model which I put up earlier on, the log specification where we linearise the gravity model. And Berger argues basically that when you estimate those sorts of models, there's three potential issues that may well arise. The first is the sort of standard logarithmic transformation bias, where if you want to take the expectation of the log, it's not equal to the log of the expectation. So there's that problem in the log normal gravity model, but also there is issues in relation to heteroscedasticity, and particularly if you have excess zeros, you might run into trouble estimating those sorts of models. So what Berger has argued within the context of gravity models of trade flows is that it might be better to estimate count data models. And looking at the data that we had available to us, it looks very much like count data to us. Most schools have 0, 1, 2, 3, 4, 5 flows. Yes, there are some higher ones, at the tail of the distribution, but it very much does look like count data. So what we decided to do was, in this paper, estimate a series of count data models, and we compared them to the standard OLS models. We generally had better fit and more robust findings, I think, from the count data models. I think it makes sense. So that's one of the contributions we make in this paper. And in estimating these models, we have to address a number of issues. The first is over dispersion, and whether or not we estimate a Poisson or a negative binomial count data model. Clearly we have over dispersion in our data. If you think back to the mean and standard deviation of our individual flows, the standard deviation is, I think, 2.5 times the mean. So it's very easy to test for that and accommodate that by estimating a negative binomial model. We can also test directly for the presence of excess zeros. In some of the models that I'm going to show you, excess zeros were a problem. So we were able to account for that using a zero-inflated negative binomial model. But in others, it wasn't a problem based on a test called the Vuong test. So at least we're able to deal explicitly with issues or potential issues in relation to excess zeros, which is not possible or more problematic, at least in the log normal model. And then the other issue is to take account of the school level effects. So we were able to include individual school level effects. Whether or not we should have random or fixed effects is something we can test for empirically, and we find that we would like to include, or we should include, we should estimate a fixed effects model as opposed to a random effects model. And that's where things get a little bit interesting for us. At least we argue in the paper that we have something useful to add, because when you estimate a school level or any individual level fixed effects negative binomial model, what you're doing is you're essentially controlling for unobserved heterogeneity in the individual or the school. Now, I sort of happened upon this by chance, because when I estimated this model, what I found was the school level characteristics, or what we might think of as the HEI invariant characteristics, they were I was getting estimates for these variables. So if you think about any sort of standard fixed effects model, when you estimate that model, what happens is for the individual, say the time invariant characteristics like gender, say for example, are very often highest education level attained. Those coefficients will not be estimated in a fixed effects model. It's different within a fixed effects negative binomial model, and the reason for that is the fixed effect is included in the over dispersion parameter in the negative binomial model, and not within the conditional mean, which is the case in a standard fixed effects model. Now, there's arguments in the literature as to whether or not this fixed effects negative binomial model constitutes a true fixed effects model, because the fixed effect is in a dispersion parameter and not in the conditional mean. But what it does allow you to do is to at least get some part closer to identifying, you know, or arguing what you have is closer to a causal effect, or controlling for this unobserved heterogeneity. So when you estimate these models, it essentially means that you can recover the parameter coefficients for the school level characteristics. And we argue that that's a useful addition to the literature. Our model, as I said, accounts for over dispersion. In our main model, we find no excess zeros, which is good. And then the other advantage of this sort of approach is that we can, when you estimate a fixed effects negative binomial model, the estimated parameters can be interpreted as elasticities, and that's the standard sort of way of presenting these sorts of effects in the gravity model literature. So what it means is you can compare the estimates from these models to estimates, say, from previous studies which have estimated the log models there, for example. Okay, so I'm going to talk about two sets of results. The first will be the parameter coefficients from the gravity models, the main gravity models, which will give us the overall headline sort of results from the paper. And then I'm also going to talk through a set of results from a set of individual level or individual HEI level negative binomial models. So not only did we estimate the full sort of panel data gravity model, we also estimated negative binomial models of the flows of students to individual HEI. So for UCD, for example, we looked at the relationship between the flow of students to UCD and the characteristics of the schools from which students were going to. So we were able to basically recover what is the impact of travel distance for individual HEIs and compare them across HEIs. And that will become a little bit clearer in a moment when I show you the results. But to start off, and to show you what the sort of headline results from the paper are, first of all, this model here, model 1, which is a fixed effects Poisson model, is really only included to show you that if you estimate a fixed effects Poisson, all of these HEI invariant, okay, or school level variables, they drop out of the model, okay, like any standard fixed effects model. But what you recover is an estimated elasticity. Kevin, I hope you're happy that that's close enough to minus one. And then we get some coefficients out here, okay? But we know there's over dispersion in the data, so the negative binomial model, which is presented in equation 2, is preferred, okay? And we do all the usual battery of tests, and we estimate, in fact, two negative binomial models: one without county level, school level county dummy variables, and a Dublin level indicator variable for the HEIs, one without those two variables and one with. And our preferred model is the model that includes the county dummies and the Dublin dummy, okay, in equation 3 here. And what we find is the elasticity is basically minus 0.9. A 10% increase in distance reduces flows from a school to a HEI by 9%. Close enough to minus 1, whatever that means. A little bit lower than some of the previous results that we've seen in other countries, so I was a little bit surprised. I thought in Ireland it may be a little bit higher, but it wasn't. But in the same ballpark as previous studies. And really what it does is it confirms to us, you know, that distance has an impact in terms of where students choose to go to higher education, okay, which HEIs they choose. Centrality, as I said, it is highly statistically significant, and without going into the details of it, this coefficient here is practically not all that significant, okay? So just in terms of the difference between statistical and practical significance, highly statistically significant, practically not all that significant. In other words, centrality does have a statistical effect, but it's not all that big in a practical sense. The other two variables that I would sort of highlight, I think, as being important findings is the DESH dummy variable comes out as being important. So if you think about the variable, the spatial variable here, log of distance, the coefficient there can be thought of as an elasticity. If you have a dummy variable in one of these models, you can think about the coefficients as being semi-elasticities. So this minus 0.219 basically means, minus 0.271 basically means all else equal, flows of students from a DESH school are 27% lower. Now it's a little bit complicated to think through exactly what that means within the confines of one of these models, but it basically suggests something that we probably already suspected or knew, is that flows of students, all else equal, from DESH schools are much, much smaller to higher education institutions. It's just a reconfirmation of what I said at the beginning, that there are large socioeconomic inequalities in terms of accessibility or progression to higher education institutions. And then in terms of HEI type, I think what's the most interesting result here is the coefficient on Institute of Technology. What this is saying is 22% lower flows to an Institute of Technology than to a university, which is the base case, all else equal. Again, we would argue that this is probably picking up the quality effect, you know, in terms of students, all else equal, thinking about where are they going to go. They're going to go to a university more so than an IoT, where possible. So that would be they would be the main findings, I think, from the gravity models. The next thing we did then was to estimate HEI specific gravity models. So basically looking at to what extent is distance a factor in terms of determining the flows of students to individual HEI. So I'll just start with the universities first of all. We have a number of different models. We estimate firstly models with no controls. This is where you just regress the flows from every school for each university as a function of the distance from that school to that HEI. And if you do that, what we find is these little ZIs imply that we have a problem with excess zeros, so you have to estimate zero inflated models. Okay, so zero inflated models were required when we had no controls, but when we included controls, only some of the models suffered from this excess zero issue. So, for example, Trinity doesn't have a problem, or UCD doesn't have a problem with excess zeros, presumably because the big two are able to attract, you know, students from, you know, all around the country. And what you find when you estimate this variety of HEI-specific models is that distance is much less of a factor for UCD and TCD in terms of attracting students. Their elasticities, their distance elasticities, are much lower at, you know, 32, 36%. And contrast then that to the other standout in the data, which is Cork. Okay, where the distance elasticity here is much, much higher. In other words, distance is a much greater impediment, if you like, to flows of students from a school to UCC than it would be for the other institutions. And this reflects basically that UCC tends to attract most of the students from within Cork, are very, very close to Cork. And also we know the students from Cork are much less likely to leave Cork. Okay, and again, as I'm being recorded, I'm gonna keep my Cork jokes in my pocket for fear of being quoted. All right. So the point here is that there's sort of wide variation in terms of these distance effects across universities. Won't show you or talk through these. There's also wide variation across HEI types. The distance elasticities are much bigger for institutes of technology. But they're not as big for some of the colleges of education, and that's because these colleges of education are able to attract their students from right around the country. Okay, so what I'd say basically in relation to trying to condense all of this information into maybe one sort of summary conclusion is that distance matters in different ways for different types of higher education institutions, and also within those different types for different specific institutions. What's notable in the pattern of results, which we talk about in the paper, is that HEIs which are much more specialised, like NCAD or Royal College of Surgeons or the teacher training colleges, distance is not such an impediment to those as it is to other, say, institutes of technology, particularly the ones around West Dublin, Blanchardstown, Tallaght, which, you know, really don't attract students from very, very far away. So we're able to quantify all of that and draw sort of broad conclusions in relation to the patterns. But at the same time, we've only got 27 data points, so it's hard to be absolutely clear in terms of, you know, what's driving those differences in the elasticities. So I've got just a couple of minutes, so let me be brief then in terms of summing up. The key headline findings, I suppose, are geography plays a very important role in determining student flows. So too does desk status, and there's huge variation in terms of distance effects across and within HEI types. So you might be tempted then to sort of say, well, did we not already kind of know that? Okay, and to a certain extent we had a sense of it. Now I guess what we can say is we've kind of shown it in a more formal manner. So I have a list of conclusions in the paper where I say this is the first gravity model of student flows for Ireland. It offers all these additional insights. It's the first time we have a school-level gravity model. It's the first time we have a fixed effects negative binomial gravity model, and so on and so forth. So I have kind of a set of conclusions which I use to sell the paper because we're going to a sort of a methodological journal with it. But in terms of really what we really care about, what I would argue, and this is sort of going back to what I was talking about at the beginning, what we're finding in this piece of work, which I think, if we think about in tandem with the other papers that I've been involved in, is that distance plays a very, very important role in higher education decisions and outcomes. It determines, to a large extent, particularly for poorer students, where they go, if they go, first of all, and if they go, where they go and what they do. And if you think about that, those sorts of choices early in life have significant lifelong outcomes, particularly for labour market outcomes. Okay? If we think about the decision to participate or not to participate, if students are not going to higher education because they can't afford to cover these distance effects, then these distance effects are really just exacerbating socioeconomic inequalities in terms of participation that already exist. So in terms of sort of contributions of the conclusions from the paper, I have a sort of a set of conclusions that are sort of written in terms of selling the methodological quality of the paper. But what I really think, in terms of all of this work that I've been doing, is that these distance effects are having a negative impact in terms of exacerbating socioeconomic inequalities in terms of higher education outcomes in Ireland. In terms of how we might go about addressing that, if there was a sort of a one thing we had to change, I would argue we need to reform the grant system. There's an adjacent, non-adjacent grant system in Ireland whereby if you live a certain distance away from a higher education institution, you qualify for a higher payment on your grant. And that's I think it's set at 45 kilometres and it used to be somewhere around 23. I don't think that's a particularly good system in terms of addressing these sorts of distance effects that are evident, and I think that needs to be reformed. But given that we're reforming anyway, or talking about reforming the way in which higher education is going to be financed into the future, I think at least consideration of these distance effects needs to be brought in or taken into account when we think about how we might go about financing and trying to tackle socioeconomic inequalities in accessibility into the future. The other people who should be sort of interested in this sort of thing are HEI presidents. I'll skip the first bullet point, but maybe just to mention the second bullet point. One of the things that's coming out of this particular paper, but also the other work that Sharon is doing, is that quality and specialisation really matter for students in terms of choosing where they go. Students really value, and it's coming out in our DCE, the quality of course and the quality of the institution that they study at, or that they want to study at. They're willing to pay more, or their willingness to pay is higher for these sorts of attributes. But the other thing that's important is specialisation. Students are willing to travel for specialised courses, and they're not willing to travel as far for courses. If the same sort of course or some course that's relatively close to UCD BCom is available to me in WIT, well then I'm going to be less likely to travel. And that might matter to HI presidents, particularly in a more competitive higher education sector. If you're trying to attract students, from further away, higher levels of specialisation, I think, might be more likely to do that. Okay, I'll skip the further work, just to leave a minute and a half for questions. And finally, I'll just say thank you very much, all of you, for coming along and for your attention today. Thank you.
Okay, we have a couple of minutes for